All right, so to finish lesson 311, we're going to do this. So we were on multiplying and dividing rationals. So the first thing here is multiplying a rational function. So what we have here is our two fractions, right? And we're gonna multiply those. So again, when you're multiplying it straight across, okay, so almost like the multiplication is not even there. Okay, so the first thing we need to do is factor anything that we can factor. Okay, so this is already factored for us. So the only thing we can factor here is the top or the numerator on the right function, the right fraction. So if we factor this, we can factor out an x. So what this will look like is 12 x plus 9 to the fourth over 8x. Factor out an x, and so I'm left with x plus 5 over x plus 9 to the 12th. So then we're looking at what can cancel. Okay, so in this case, I have 4x x plus 9 to the fourth. Down here I had 12, so this is going to become an 8. I have one x that can cancel, and then 12 over 8 will reduce. So what I'm going to be left with here is 3. Again, this will reduce if I divide by 4. This is 3 over 2. So this is 3x plus 5 over 2x plus 9 to the 8. And that is simplified. Okay, so looking at the next one, so now we have division. Okay, so when we're dividing, what we have to do here is, everybody uses the gimmick, keep, change, flip, right? But it's multiply by the reciprocal. So we're going to go ahead and write it that way. So we're going to go ahead and write 5x squared minus 14x minus 3 over x squared minus 9. We're going to multiply by the reciprocal. So 2x squared plus x minus 1 is going to go in the numerator. And 5x squared plus 6x plus 1 is going to go in the denominator. So then what we'll be able to do is factor this. So again, factoring a trinomial, by now you should know how to do that. Whether it's box method, mass product, slide divide, whatever it is for you, you got to be able to do that. So we're going to factor this. So 5x and x, the 3 is going to go with 5 to make 15. We'll make it negative. And plus 1 is positive to give us 14x. The bottom is a difference of squares. So this is x plus 3, x minus 3 times. Again, we got to factor a trinomial. Okay, so we have 2x and x. Okay, this is plus 1 and minus 1 over, again, factoring a trinomial, 5x and x. This is plus 1, this is plus 1. So now, looking at all of this, what can cancel out? So again, 5x plus 1 will cancel. X minus 3 will cancel. X plus 1 will cancel. And we're left with 2x minus 1 over x plus 3. Okay, so you get the idea there of multiplying and dividing rational functions. Okay? So if we move on here and we look at 3(5), what they ask us is 3x over 2x plus 5 plus 12 over 2x plus 5. Is that equal to or equivalent to 3x plus 12? So they added the numerators, 3x plus 12, over 4x plus 10. So they added the denominators too. Okay, the correct answer is no. Those are not equivalent. Why? Because when we add fractions, we have to have a common denominator. Okay, well, we do have a common denominator here. So we can add the numerators, but the denominator stays the same. So what should happen here is this should be 3x plus 12, but it should be over 2x plus 5. Okay? So moving on there. In order to determine the sum of the fractions, they must have the same denominator. So how can we do that? All right, so how can we rewrite the denominator so that they are the same? All right, so looking at this, okay, we have 3x over x plus 1 plus 7 over x plus 1, x minus 6. Okay, what is needed for the denominators to be the same? Well, coach, they both have x plus 1. Yes, absolutely. Okay, so my left fraction needs x minus 6. So I'm going to multiply by x minus 6 over x minus 6, which is a value of 1. So we don't change the value of the fraction, right? And so what do we get here? Let's go ahead and distribute the top, the numerator. So 3x squared minus 18x over x plus 1, x minus 6. Don't distribute the bottom, just leave it. So the denominators will be the same. My marker's going bad here. Okay, so now the denominators are the same. We can then add. So we have 3x squared minus 18x plus 7 over x plus 1, x minus 6. Okay, and then you could look to factor this. This would be 3 times 7. Factors of 21 that add to 18. There's actually not any, so it's not factorable. So that's the final answer there. We would just leave this. Okay, so in order to add rational functions, we have to have that common denominator. Okay, so what I would say now is on your own, I want you to go ahead and try A, B, C, and D. I want you to try those on your own. Again, you're going to have to factor. So if you're looking here, this is a difference of squares. So this is going to be 4x plus 1, 4x minus 1. Then we can see that 4x minus 1 is going to be in both fractions. So the right fraction is going to need a 4x plus 1 to make the denominators the same. Okay, so being able to do that. Okay, so that's kind of where I want you guys to stop today. Is I want you to try these on your own. And then once you're finished, what I want you to do is go ahead and go to your review preview and start on your homework.